If you are asked to sketch a quadratic, you need to remember two things. The first is the shape. If the x squared part of the equation is positive, you're looking at a smiley shape. If the x squared part of the equation is negative, you're looking at the kind of a frown, the opposite way around. If you can remember those two things, you're off to a good start. Kind of equations you might see where it's hidden are here. A positive, for example, on the left here, could be outright in your face positive. It could be moved to the right, which is not ideally where you're used to seeing it out front. And you might have to expand it, noting that the only way to get the x squared is the multiplication of those two, which ends up being positive. Similarly, for the negative over here, it's either outright, it's moved to the right, or when you expand with the two, you have a negative multiplied by a positive, which will lead to a negative result, knowing that you have a negative quadratic. So first mark in the exam is from shape. Second, potentially third point is that we find the y-intercept by setting x to 0. You can see on the graph here that this point where the y-axis is where x equals 0. And if we just substitute the 0 into the equation, what we'll be left with is the intercept. This is usually the number in the equation. If we want to find the points where it crosses the x-axis, here or here, for example, these are called roots, and we factorize to find them. They're the points where y equals 0, and that's why in order to find them, to solve an equation that's quadratic, we put it equal to 0, because it's the same as setting y equal to 0. And when we factorize to do this, we are putting them into a position where we could find those two values of x where y equals 0. So let's have a look at some questions and how we can sketch our quadratics. We don't want to be drawing any kind of scale for our quadratic. The problem is when you're asked to sketch, people often think it's plot and it's too detailed. So here's an example where it's already done the factorizing for us, so we can straight away take out our results. The best thing to do is to look at each of the factors separately. We've got one here x, one here x minus 7. And if either one of those was 0, then we have a solution for when it's equal to 0, right? So we take each one, we say x, the first factor, x equals 0. Well, straight away, if we set that factor equal to 0, we have the answer. We have x equals 0. That's one of the roots. You could call that alpha 1, or you could just call it root 1. It's up to you how you label it. Some people don't even bother. They just know they need two x values, because quadratics typically have two solutions. If we look at the second factor, we've got x subtract 7. If we put that equal to 0, we're literally asking a question here mathematically. When is this factor equal to 0? That's what we want to know. And by solving this, we are answering that question. We add 7 to both sides. We get our two solutions. I'm going to put them in boxes. That's my equivalent of labeling, I suppose. And now we're going to hopefully find the y-intercept. So in order to do that, it's best to expand out the bracket so we can see what's going on a bit better. And we have this. So this is the equation that we're looking at. And instead of it being equal to 0, where y equals 0, we can just write y. And looking at it, if we have x equals 0, so we can just make a note of what we do as we go along. When x equals 0, we can see that that would be 0 squared minus it would be 0. So we have this point where it's going to cross the axes, and that's at the point x equals 0. So we can plot that. We can say it's going to cross the y-axis there, and it's going to cross the x-axis at that same point, but also at 7. Now it's really important that we remember you don't need to have a scale here. You just need to put the important points. The important points are the x-axis crossing, and sometimes the vertex, and the y-axis intercept, and I guess the shape you could call, but it's not exactly a point. Now we've noted that when we expanded this quadratic, it was a positive x squared. So we're just going to draw a smile and make sure that we try and get through those points. Take it slow. And sometimes if you hold the pencil a bit further back from the tip, it's quite a nice curve. We can label this now. This was the equation y equals x squared subtract 7x. Next example. We have the two factors. It's already factorized for us again. We'll set them equal to 0 and rearrange. So we get a equals 2. And the second one equal to 0 and rearrange. So you'll notice that this time one of them is negative. That's fine. When it's negative, it just gets plotted in a different place. We don't want to draw these to scale, but we could draw them relative to each other. So if 2, the wrong side there, if 2 is here, then -7 ought to be a little bit further away on the other side. You'll notice that that's technically 6 away, but we don't want it to be perfect. It just has to be roughly correct. Okay, so now we're going to find the y-intercept. If we expand these brackets, the only thing that is going to end up creating a number, a pure number, is the 7 times 2. Now you could expand this whole bracket and then substitute a equals 0 in, and that's fine. So technically we're saying here a equals 0, but what that's going to lead to is getting rid of all of the a terms and just leaving you with that number. So I could tell that at this point we're going to have a y value of 14, and I said earlier, generally that's true. When you have a quadratic, the y-intercept is often the number that's in the equation. Okay, so we've got an intercept up here of 14, which is rather high, and at this point you could extend your axes. So we're just going to do that now, because by extending your axes you have some sort of relativity. As I said, you don't need to plot it perfectly, but 14 is quite a large number in comparison, so let's just put it up as high as we can in a way, and that's going to be our 14 up there. Now looking at the expansion of these brackets, the only way to get our a squared term is these two things multiplied together. You can see that's going to be a negative a squared, so this is going to be a negative quadratic. We can see that this will probably have some sort of midpoint to the left of the y-axis, but I'd probably want to start down the bottom with the frown shape, because we want to make sure we hit that 14. And it doesn't have to be perfect, but it's probably going to want to be going through as many of these points as possible, as closely and smoothly as possible. Okay, so I'm pretty happy with that. It's smooth. We can't have jaggedy edges. We don't want it to be going around, suddenly changing and then carry on like this. We want it nice and smooth and clean and going through the points, and I think that's achieved. We're going to label it. I guess we can finish, and technically we could label it. If you didn't want to expand those brackets, you could label it just like this. Okay, so that's when we've got factorized quadratics already for us. Clearly, if you don't have it factorized, you want to do it. So it might look like this as a more basic form. and you have to factorize first. This one's a basic factorization. We can see x goes into both. So we'll take that x out and we'll end up with this. Putting each factor equal to 0 and rearranging, we get these. So I actually like to write that the other way around. Now at this point you could probably see you don't need to write them equal to 0. If you want to just use the pattern that it's the number that gets the bracket equal to 0, and in a lot of cases, standard cases, that would be the number with a different sign in front of it, then go ahead and do that straight away. And we look at the y-axis now. It's clearly going to be 0 when there's no number term in it. It's 0. We could obviously say that we've got x equals 0, but the y-intercept in this case is 0. We can tell that from the substitution. And when we put this all together, we've got a cross here. We're crossing again at 0 in terms of our x-intercept, but we're also crossing at 6. Now looking at the shape, this is clearly a negative x squared. It's expanded. So this is useful if it's not yet factorized. You can see sometimes quite quickly which we have, which is a negative x squared here. And so with this, we're going to be drawing our shape through the axes like that. Okay, label it. And you have your drawn sketch. Last one. Factorizing this is a little bit more complicated, but technically you're able. There is another video on my channel that does this if you want to have a look at it. I'll be trying to make as many different ones as possible. So we have two brackets. 18 factorizes quite nicely. I think 3 and 6 will go for. And we're going to have to subtract both of those to get to -9. Leading us to factors of 6 and 3. Obviously you could have go that yourself and come to the same conclusion and use this as confirmation. So 6 and 3 are our intercepts. What are they going to roughly look like? We don't need much of the left hand side of this graph, do we? Let's just call it here and here, and we can label those off to the side. Off to the side is quite good in a sketch because you don't need it to be 100% accurate with regards to scale. It's not scale, and it gives us a bit of room to draw. Now the y-intercept is when x equals 0. Okay, so for that, that's going to lead to this term and this term disappearing, so we get y equals 18 for our intercept. Now, in terms of everything here, I'm not sure I'm going to enjoy putting this in a relatively good position. What I could do is draw my general quadratic, knowing it has to go through the y-axis. So let's just say something like this. Going through my points, taking it nice and slow if you need to, nice and clean, and I can label my y-axis wherever that happens to be. Now technically there's no scale needed with these, so you can label where it ends up crossing, and if that makes your sketching a lot easier and clean, then there's nothing wrong with that. You label it as that point, it becomes that point. So there's a bit of flexibility with the sketching because scale is going to change. But that's how you sketch a quadratic.